Hello and welcome to the SimLogic webinar, OEE, the critical KPI to kickstart your Industry 4 journey. My name is Claire Healy and I'm your facilitator for today's webinar. So today's webinar will be recorded, so we will ensure the recording sent to you in the following days. So just a brief note on housekeeping. So we want to make this webinar as interactive as possible. So if you have any questions, during the webinar, please use the question panel on the right-hand side of the screen and we'll address these at the end. If we do run out of time, we'll try answer your questions. We will answer your questions via email. So now I'd like to hand you over to today's host, Fraser Thompson, who's the Business Development Manager at SimLogic. Over to you, Fraser.
Thank you very much, Claire. So as Claire mentioned, my name's Fraser. I've been working for SimLogic now for about the last 8 years and have an engineering background. More recently moved into the MES, or what's now called the MOM arena, looking at manufacturing operations management. And I get involved in many projects within SimLogic in many different sectors, really, from food and beverage to pharmaceuticals, CPG, oil and gas. And I like to think that we can take experiences from different sectors and apply them where you wouldn't normally apply them. For example, taking learnings from pharmaceuticals, trying to apply those to food and beverage, and so on. All the time thinking about how we can leverage software to help us improve manufacturing, and thinking about lean manufacturing principles. So using a software angle is how do we start to adapt to Industry 4, and that's kind of my key role at the moment within SimLogic. So a little bit about SimLogic. We're based over in West Yorkshire. It's a lovely part of the world. That's our office building there on the left-hand side. World Heritage Centre. We like to say that this particular building, Salts Mill, was involved in the first industrial revolution. It was built in 1853. Was part of the kind of textile mill revolutions in the West Yorkshire region. So 150, 160 years ago, looking at Industry 1, we're now on the verge of Industry 4, as Siemens have coined it, and we're trying to do that from the same location where all those years ago they started to introduce machinery to help them improve their textile manufacturing practices. So we have a number of people with lots of different skills in-house. We have control systems engineers that are used to working with PLC SCADA systems. More recently, you might call them operational technology engineers, or OT, and that really is just a modern name for what we used to call automation systems, PLC SCADA, but now would encompass things like printers, RFID, barcode scanning, and all the kind of technologies that you might use on the shop floor to help drive the operation. So we have a mixture of those engineers. We've got a mixture of software engineers that are used in our MOM or MES projects. But then also we have a service and support team that look after our clients' projects and implementations on a 24/7 basis. And we also have an operational excellence team that are charged with essentially using the information and the data that our software systems generate to help you drive manufacturing performance improvements. And that's quite a key part of it, really. Technology is only one part of the journey. You also need to consider how you take people, organizational structure on the same journey as your technology. So that's something to bear in mind and think about as we discuss the rest of this webinar. So some of the things we're going to discuss. Firstly, we'll keep it quite simple, looking at OEE. OEE is a good way in. It's a good way in for MES or MOM systems. It's also a good way into Industry 4. It's a good way to kind of kickstart your journey, as we've said there in the agenda. So we're going to look at how those principles and the data collection that we can offer can help you start the journey towards Industry 4, ultimately to get you to where you need to be to remain competitive for the next few years. And we've got some screenshots in there. We can go through some examples of the data that we can generate also. So firstly, I always like to start with a quote where possible. It's one of my favourite quotes, and I'll read it out. It's by H. James Harrington, Measurement is the first step that leads to control and eventually to improvement. If you can't measure something, you can't understand it. And if you can't understand it, you can't control it. If you can't control it, you definitely can't improve it. I think that's very, very apt, certainly in our industry, but it could be said that you could apply that same theory to anything really. Take, for example, if you're baking a cake at home, if you can't measure the ingredients, if you can't weigh out the flour or count the eggs or measure the milk in a jug, you essentially can't control the final product, i.e. the cake, and without being able to measure it, you're not going to know where you went wrong. How can I improve the recipe of this particular cake to ensure that it comes out correctly? If I can't measure the temperature of my oven, how do I know if I've had my cake in there for long enough at the right temperature? So we're using those principles, applying them to the manufacturing industry across all verticals. So how do we do that? We like to say that OEE is kind of the critical KPI for manufacturers. A lot of people would say overall equipment efficiency. I would hasten to correct them. It's overall equipment effectiveness. What's efficient is not necessarily effective. We can have completely efficient processes that all they do is consume more raw materials and generate more work in progress for our organisation, and not necessarily yield more product out of the door, which is the end game. So as a part of our plan to improve, it's very common for most manufacturers to have a desire to either increase their capacity or decrease their time to produce. Maybe we want to go from a 7-day shift to a 5-day shift. Maybe we're looking to get an extra 10% capacity this year. We want to obviously get return on our assets, and we want to get the best return possible for our assets. We want to improve our conversion costs, our cost of converting raw materials into finished goods. We want to reduce our operating costs. That might be labour, it might be the cost of raw materials, the cost of scrap. Essentially, we want to better manage our capital. We want to focus our funds in on the areas that are going to yield us the biggest bang for our buck, if you like, the biggest improvement for our efforts in continuous improvement. And the end game for those that are listed companies, again, is to increase the shareholder returns. So OEE, we believe here at SimLogic, is the critical KPI and the best methodology to help you drive the productivity of your manufacturing processes. And we're going to show you a little bit about why we believe that is. So firstly, OEE, what's it made of? For those of you that are familiar with it, this will be fairly simple, but I thought I'd give a very quick introduction for those that might not be familiar with OEE as a measure. What we're doing with OEE is we're breaking it down into three measurement areas: availability or availability losses, performance losses, and quality or quality losses. And I like to keep the lines quite clear between the three. Availability, I would say, is a machine breakdown. It's a period of time where we are planned to be operating, but we have a machine availability issue, which means that we cannot produce. Performance, I like to say, is all to do with the speed of production. So if I'm available to produce and I am producing, how fast, at what rate am I producing goods against the theoretical rate at which I should be able to produce goods. So that would be, for example, if I have a filling line that is able to produce 100 bottles per minute, but is only producing 80 bottles per minute, although it was running all of the time, that essentially is a performance loss. So our performance would be at 80% with a 20% loss. Sometimes people like to think that performance losses can also be downtime of the equipment or of the machinery that's not related to a fault of the machinery itself, but of the process and of the operation. So the fact that I need to perform a label reel change on a labeler, for example, is not necessarily a breakdown of the equipment, it's a fact of life. I need to change these labels, and therefore some people like to record that as a performance loss. And that's perfectly acceptable. You could do that either way, as long as you're careful about how you baseline your performance and your availability targets. And quality is where it can get quite tricky. So quality would be the percentage of parts which meet the specifications, are saleable goods. If 100 bottles went into the process and we rejected 2 bottles because they had a metal detection issue, then again I've got 98%. I've got 98% quality, a 2% quality loss. But quality losses can be quite difficult to measure, and difficult to measure accurately without going into a lot more detail and looking at vision systems, looking at full statistical process control systems. So quite often we'll find ourselves looking at quality and saying, let's look at it slightly differently. Let's measure our OEE of our production line, for example, as just availability and performance. So that's some of the common things that people do along those areas. How does that look on a little chart? Well, hopefully this explains it quite nicely. We've got here our total available time. Let's say there was 24 hours in the day, but for 4 of those hours we didn't plan any production. So that would typically come outside of the OEE calculation as a planned shutdown. Some people might say that actually, I had this equipment, it was there, it was able to be used, all I needed to do was turn it on and staff it correctly, and would incorporate that in their OEE calculation. We in this sense would include it in what we'd call a TEEP, a Total Effective Equipment Performance calculation, rather than OEE. So we would then take our planned production time, take off any downtime losses, availability losses to give us our operating time, look at our performance or speed losses here to give us our net operating time, and take away our quality losses or our defects to give us our total productive time. So of the total planned production time we were producing for the productive time, and one divided by the other should give us the same result as availability times performance times quality as a percentage. And that's how we're going to go about calculating OEE. Now, a lot of people currently will be calculating OEE and other metrics on the shop floor using paper-based systems. Operators would write down on a piece of paper on the shop floor every time they see a downtime event, and then at the end of the day or at the end of the week somebody would compile that. It would be somebody's job to compile all of those bits of paper and put them into Excel, save that Excel sheet somewhere on the network. All we're essentially doing here is we are gathering information. We're spending a lot of time to gather information, and we are generating information that is not necessarily accurate. It's often inaccurate. Quite commonly you will see time periods that are logged in 5 minutes intervals or 10-minute intervals. We had 5 minutes downtime for this, 10 minutes downtime for that, 60 minutes for the other. And you'll also see that you find yourselves reacting to yesterday's information or reacting to last week's information, whereby the opportunity to do something about whatever the issues might be has already gone. I once had a client tell me of their current paper-based system, we know it's wrong, but we use it anyway. And that was quite galling, really. To say that you are basing business decisions on information that you fundamentally know is wrong surely doesn't sit right. It certainly doesn't sit right with me, and hopefully it wouldn't sit right with you. So what can we do to make that better? Well, the next obvious step from manual operation is to look at how we automate that. So how do we take the logging of downtime and speed information away from paper and into a real-time system that's easy to operate, that can engage operators? And it can be quite simple. So automated systems will give us real accurate information. Equipment will tell us exactly when it stopped and how long it stopped for. It was 2 minutes and 35 seconds, so it's not 5 minutes or 10 minutes. It's an accurate representation of the actual time lost. But also you'll start to pick up things like short stops that might have been 10 seconds or 15 seconds that to the naked eye are very difficult to capture. You could turn your back on your production line for 30 seconds, have a quick conversation, turn around, and in that period the line could have stopped and started itself a couple of times potentially, and you would have missed that. That's a missed opportunity to use that information to try and improve. But also the advantage of automated real-time data is that you can get accurate indications of running speed. And again, I'll use the example of a production line that's supposed to be running at around 100 bottles per minute. It'd be very difficult with your own eyes to try and distinguish between the line that was running at 100 bottles per minute and the line that was running at 96 bottles per minute. I would challenge any of you to see if you could pick that up just by looking at it, but it's, that's a 4 bottle per minute opportunity that's missed, and if you multiply that up over the hours, over the days, over the years, that's quite an opportunity missed to have some additional production. So it's important to get from automated systems real-time, accurate, believable data, but also to still engage the operators, because these are the guys on the shop floor who are charged with production on a minute-by-minute basis, on an hour-by-hour basis. If there is something going wrong here and now, they are best placed to do something about it. So we need to make sure that we engage them and we provide them with the information to do something about it. However, a word of caution. We need to think that correlation is not causation. It's a topic that's quite common in kind of scientific worlds. If you're performing experiments, that you just don't jump to conclusions because the data looks to point you in a certain direction. A good example of this, if you Google around on the internet, is global warming. If you plot, as you can see here on the page in front of you, the global average temperatures versus the number of pirates, you can see here that if we're trying to reduce global warming, what we need to do is we need to increase the number of pirates in the seas. There's an obvious correlation there between the two, so surely they're related. You can be very quick to jump to conclusions. And you can do the same with OEE data. It's very, very important to be careful about what you record and how you record it. For example, if you automatically captured information from your production line that told you that your top availability loss reason was your labeler, you could very quickly jump to a couple of conclusions there. You could jump to the conclusion of what I need to do is I need to schedule some maintenance. I'm going to schedule a 2-hour window where we're not going to produce. We're going to do some maintenance on this labeler because it keeps breaking down. We're going to send an engineer down for this 2-hour window. He's going to refit part of the labeler, and away he goes. And hopefully, touch wood, everything works when the maintenance window is finished. That's one example. A slightly more extreme example would be that again, you're using that information to say, what I need to do is I need to buy a new labeler. I need to go out and spend £30,000, £50,000 of capital on a new labeler, get that installed, get it commissioned on the line, lots of downtime, lots of capital expenditure. And that's kind of the danger of manual data as well. We are jumping to conclusions and we are using information where we don't necessarily have the whole picture to jump to a conclusion and make a decision on it. So we need to be careful in the same way with our automated data. We need to ensure that we have the right amount of context to our data. We need to know, do label jams on this labeler happen more when I run product X or product Y? Do they happen more when I use labels from supplier A or from supplier B? Does it happen more at night or more during the day when the early shift is on or the late shift is on? We need to make sure that we have as much context to our data as possible so that we don't jump to these incorrect conclusions. So we might find ourselves in the situation as described by the picture. I think that's the best way of putting it, that you are currently drowning in paper. If you are capturing information from the shop floor, you will be generating lots and lots of paper. You will be generating folders and folders of paper, Excel spreadsheets that can get stored away on your network, that take up network space, that take up filing cabinet space. And if they all get used as much as they should, I would be very surprised. So we want to take a step away from this paper-based world. We want to move to a digital world that is promised to us with the Industry 4 speeches and the talk that everybody in the industry is giving us currently. We want to move to the digital world. But a big caveat there is we need to be very careful about doing that, because we can go from one extent of being drowned in paper to being completely drowned with data. We need to make sure that through careful selection, we take out the data and the samples that we believe or that we know to be relevant in this particular case. So I like this. The picture on the screen here is the chap there is essentially filtering the data to give him just the right information that he needs to help this plant grow at the bottom, and everything else is just letting fall around him. It's not necessarily that important. But how do you define what information is important to you? And that has to be a little bit about, from my perspective, it's about starting simple, asking simple questions, seeing where the information leads you, and then looking for more information so that you can drill deeper in and ask more detailed questions as you go. So here's a good example of that. So starting simple. If I want to start simple, let's say I just want to count production. I want to count the number of units I've produced over the course of what is here a 12-hour shift. I can see that I start up around sort of 7:20. I get up to a good running speed, I run for a bit, and then I have a minor stoppage just before 8, and then a major stoppage at 8 till about past, then I run for a bit more, I have another stoppage. I can see there that that's one data set. That's one bit of information from one sensor on one machine that tells me this is how fast I'm producing units on this particular machine. If you can also deduce from that the total number of units that you produced over the shift or over the day. But that's only so good. I could look here and say this period of time between 12:30 and about 1:15, I'm obviously not running. But I don't have any information to tell me why I'm not running, or what's the cause there, or what's the cause of this downtime from 2 till 3. Is that an expected downtime? Is it something out of the blue, out of the ordinary that I need to be worried about? So we need to think about how we can add more data, ask more questions of data to get better answers. So the next thing I've done to that chart there is I've added 2 lines on there. We've added some context to the data. We've added, not only have we got the rate at which I'm producing products, but I've now added the target rate at which I'm desired to produce products, and also the theoretical rate at which the machine should be able to produce products. So I can see here straight away that this period here, about 7:20 to about 8 o'clock, I'm producing at the target rate. So if I continue to produce a target rate, I would expect to fulfill my orders. However, I've left myself a little bit short because there is an opportunity to make a little bit more. The equipment says I should be able to run at this higher rate here, around 210, and I'm actually only running happily around 180 units per minute. So that's one thing I've learned from this extra data point. What I've also learned is that here around 10:30, this period of downtime here looks to be because of a product change. The equipment has taken itself from a target rate of around 180 and boosted that up to around 200, 210. So we can see there that I've changed product. Maybe I've got a smaller product that I should be able to run faster, but I can see that when my line has started again, it doesn't appear that the actual production rate of the equipment has changed at all. So maybe there's a setting that's been missed. Maybe an operator has missed a set point, they've forgot to turn the speed up. Who knows? We need some more information. But this is a start. I've got some more information here to say what is going on. I can also say, for example, I know that was a product change because I've changed the speed profile of the line here. So I can say that this half-hour period between these 2 intervals is due to a changeover. And likewise, I can see I've changed again here to a slightly different product with a slightly different run rate. Again, no change in the speed of the machine, but I can also see that that product change has taken about an hour, whereas this one took half an hour. So is that good or is that bad? What was the target product change to go from this product to this product? And what was the target change over time to go from this product to this product? And again, we need more information. We've got to ask another question of the data to be able to get better answers. What else can we ask? Well, we can ask what kind of events have been happening on the line to give us this profile of speed. So, for example, here I can see if the line is just not running for whatever reason, or if the line is in fault for a particular reason. So I've got green is running, yellow is just not running, and red is in fault. So I can see here that these changeover periods are blocked out in periods of yellow time. I've got this little stop here that was obviously a fault, and then multiple little short faults in here. So using this kind of information, I can then deduce what are my short stops, what are my long stops, where are the issues where I need to focus in on. So every time asking another question of the data, looking to get that little bit more information that can help us drive improvement. What if we're able to add some context to an operator? You cannot get, or I've struggled to find yet, a PLC that will tell you that its operator has gone for lunch and that's why it's turned off. The machine or the PLC within the machine will tell you that it's stopped or it's been turned off, or the operator pressed stop, or they paused something. You need to combine the best of automated data with the best of information from people and some real context. So here, for example, the operator has told me that this period from about 12:30 to about 1:15, they've gone for lunch. So again, is that good or is that bad? How long are they allowed for lunch? Are they allowed half an hour for their lunch? And actually it's taken them 46 minutes. Is that because they were away from the line from 46 minutes, or was it because they were away from the line from 30 minutes and then took them a further 15 minutes to start the line up again? So you can see how every time we see something we need to ask another question, we need to drill in a little bit further. So hopefully that's painted a little bit of a picture for how you can start quite simple and then build on your data set to get you more and more detailed information to hopefully drive better business decisions. That's what we want to get out of this. We want to drive better decisions. We want to make better decisions on how to improve or how to reduce our costs. And how do we relate that to Industry 4? Well, I think it's fairly fundamental, really. Industry 4 for me is about connecting machines and equipment and devices together with people and with the processes, and bringing all of the data together into a common place to make better business decisions. True Industry 4, I believe, would say that those business decisions would then be made automatically and fed back to the control system, so the system is constantly in a feedback loop state, in a constant learning state, not necessarily reliant on people to make those interventions. But again, we have to start somewhere. We can't go from a situation where we have no or very little data and a lot of manual intervention to complete automatic control overnight. We need to take baby steps. And for that reason, something which I think the smaller to medium-sized manufacturers currently might think is outside of their reach, this thing called Industry 4 and big data, that's something for the big multinational blue chip companies that have tens and 20 production sites in this country and around the world. We're a small manufacturer. I've got one site in the UK. I produce widgets on a reasonably small volume. Industry 4 is not for me. I would say at that point, you're wrong. You have an opportunity. As a small to medium-sized manufacturing company, you have an opportunity to perhaps react quicker, to adopt these principles quicker than some of the larger, more politically time-constrained organisations. And in order to do that, you need to consider how you can break Industry 4 down into bite-sized chunks. So don't be confused or bamboozled by all of the terminology around data lakes and IoT, big data, smart manufacturing and so on that make it seem like an intangible, very large capital expense that's just over the hill and a little bit too far away from us. You start very simple. Start with a single data point. Start with a single data point on your journey towards Industry 4 and then step it up. Look and say, okay, now I'm going to do 2 data points. Now I'm going to do 3 data points. But at each point you add more data into the system, you're making the right choice. You're not starting with 6,000 data points and then trying to understand which 10 actually drive your production. Start with 1, 2 and build up to the 10 that drive production. You're then focusing your capital and your budgets in the right area and not spending money on data that you don't necessarily need. So this is very much key to Industry 4 as I see it for the small to medium-sized manufacturer in the UK. gather your real-time production data in the simplest way possible, generate your KPIs, get valuable insight, ask the right questions, and then build on it. And build on it to hopefully improve your efficiency and reduce your downtime. So how do I start? How do I know what to do? Well, hopefully this is where we can help as SimLogic. One of the things we're looking to do is offer an auditing process that helps you kind of kickstart your Industry 4 journey. And we've kind of defined it into a few easy to understand steps. So the first step of which is to look at, to access and evaluate all of your existing IT and OT infrastructures. So what does that mean? Well, to capture data, you're going to first need somewhere to store data. You're going to need to get data from the shop floor to this storage location, and then you're going to need to present that data somewhere. And that might be one of two ways. It might be on-site, networking, and IT hardware, or it might be cloud-based hardware. Again, lower cost, lower initial cost of ownership, an easy way to start yourself on this journey. Number two, look at the current state of operations and consider the future state. You need to constantly bear in mind where you want to be. I think a good analogy there might be the sat-nav in your car. At every step, as long as you've put your final destination into your sat-nav, at every roundabout, every junction, it's going to tell you where you need to go. So without an idea of where you're heading, you're not going to know the directions you're going to need to take along the way. So that's something very important to consider up front. Number three, always keep in mind the key objectives that need addressing. What is the objective? Is it to reduce the conversion cost? Is it to get the number of shifts down? Is it to reduce overtime? Is it to get more production? And again, OEE, a very good metric for no matter which one of those things you are trying to achieve. Number four, understanding how data is collected and presented to establish any flaws in existing system and processes. Hopefully we've covered that off with some of my examples there earlier on in the presentation. And then number five, at what level of operation your organisation falls under and what steps can be taken to move up the ladder. So what do I need to do beyond just data to achieve operational excellence? Do I need to employ a control systems engineer that knows a little bit about IT networks, that can not only fault find a PLC, but he also understands how to diagnose a communications issue across a switch, for example? The point is that the technology is available now, and it is available to everyone. It's not just something for the big boys, the big companies, the big blue chip companies. It is affordable, as long as you know where to look and where to do it and where to start, and to start simply. So in terms of achieving operational excellence and Industry 4 standards, again, our five steps there is kind of, again, just pictorial. So when we share these slides with you a little bit later, hopefully you'll get to see that. Maybe that will stick in your mind as a stepwise journey to be able to take. So I'm going to skip the TrakSYS live demonstration for now on this particular demo. Hopefully the screenshots and bits and pieces that we've shown you there in the webinar have been useful. The software platform that we use as part of our Industry 4 journey is called TrakSYS. So TrakSYS is a tool that allows us to connect to the shop floor, that allows us to connect to the ERP system and bring these data sources together with information from people to reduce work in progress, reduce downtime levels, reduce overtime costs, and increase overall profitability of our business. That is what we are intending to do. So some of the customers that we work for, detailed there on the screen. Please feel free to give us a call and ask us about any of our recent projects and how we've helped those customers on the screen. Or also please feel free to ask us about our Industry 4 capability audit. We've got a very nice stepwise program, as we've described there, where we can come along and see where you currently sit and how you go about taking your first steps on your journey to becoming a smart manufacturer or an Industry 4 manufacturer. So at that point, I'm going to pass you back across to Claire to wrap things up.
Oh, that's great. Thank you, Fraser. I think that was a really great insight into the simple but yet effective tools that can be used to help kickstart an Industry 4 journey. And it's also interesting to note that, like Fraser said, Industry 4 is, it exists in many existing sites, manufacturing sites, and it shouldn't be out of reach for the smaller sort of SMEs, etc. So if you are interested in learning more about OEE and Industry 4, we have 2 dedicated web pages on our website. You can download ebooks, white papers, recorded webinars. So if you take a look at them, you'll be able to find out our OEE systems and how they can basically help kickstart your Industry 4 journey. So if you have submitted any questions during the presentation, we'll respond to you via email. And a reminder that we will be sending out the recorded version over the coming days. So please feel free to pass along, share them with your colleagues as you see fit. And if you would like to discuss Industry 4 further with us or any of our OEE systems in more detail, please email inquiries@simlogic.co.uk or feel free to give us a call on 01274 599 955. So I'd like to thank you for joining us today, and we hope you enjoyed the webinar. Thank you. Bye.